So again, welcome everybody to tonight's webinar from the National Weather Service in Boston. I am Joe Deli Carpini, the Science and Operations Officer, and we're going to talk about 4 events that we had in July that included flash flooding and severe thunderstorms. So let's get right to it. We've got quite a bit of material to go through tonight. All right, so as an overview, in case you don't remember, and I was having trouble remembering this after a busy week, we really turned active in mid to late July. We had several flash flood and severe weather events here in southern New England. You can see the dates marked on the calendar there, the 16th, the 21st, the 27th, and 29th. And on the lower left is kind of the prevailing weather pattern. You'll notice a big ridge of high pressure here over the desert southwest, which is really the heat. And of course, that's still centered over the central part of the country this week. But notice across the northern tier of states, you've got pretty much a west to east flow. Notice there's a few flags there, which are showing some pretty strong winds. So it's this fast flow combined with some disturbances. You kind of see a little bit of trough here every few days. That really helped produce a lot of these severe weather events. So we'll get into some of the details, but overall, that was our prevailing pattern. So it was a wet month in July. As you'll notice, it was the wettest July on record for Hartford with just short of 14 inches. And it was the second wettest July on record for Boston, Providence, and Worcester. You see the numbers there. And the interesting thing that we found out was through our CocoRa's network, and we know many of you are involved with that, and we thank you for your efforts, the highest July rainfall total in anywhere in the U.S., Canada, Puerto Rico, their whole CocoRa's network was in Conway, Massachusetts, 21.42 inches. Which is just incredible. Keep in mind our annual rainfall totals are pretty much between about 40 and 50 inches. So much of Western Massachusetts received upwards of about half of what we would receive in a year just in 1 month. So pretty incredible stat right there. And I think we'll look at the summer totals too. I think Conway is also in the lead for the greatest summer rainfall across the U.S. as well. But we'll take a look at that in our summer review next month. So the first event was July 16th, and we had thunderstorms produced flash flooding across much of southern New England, a few instances of some wind damage, and even a short-lived EF0 tornado in North Brookfield. I believe that was the first of the summer. So really not a huge severe weather event, but you can see there in Norfolk, Connecticut, quite a bit of damage there to the roadways. So that was really the main impact from this event. And there was record daily rainfall reported for Boston, Providence, and Hartford. You can see the numbers there. Pretty much shattering some records just for daily rainfall, especially in Providence, upwards of over 3 inches of rain there. So record rainfall as well. So here's a look at our radar loop, and I'll let it go through a couple times. But you can see initially, and I've got the polygons up there, the green are flash flood warnings, red is tornado warning, and yellow is severe thunderstorm warning. Notice we had a few severe thunderstorm, a few tornado warnings even mixed in. And then we really transitioned toward the end. You're seeing more of those green polygons going more to a heavy rain threat. So we initially started with some severe weather and then transitioned over to heavy rain. Here's a look at the 1-minute rainfall from TF Green Airport in Providence. And you can see a couple of interesting things stand out. You see a few peaks here in the rainfall curve. Notice, first of all, that the hourly rate over 1 minute was over 5 inches per hour, but that was, again, over a 1 minute period. The actual hourly rate is in red here, which was about 1 inch per hour. But the rainfall rates were really higher than that at times. And you can see the accumulated rainfall here by the black curve, which, again, ended up at about 3.35 inches. But it shows Providence had a couple of spikes of heavier rainfall as showers and thunderstorms moved through. So taking a look at the 500 millibar analysis, and just a reminder, this is about 18,000 feet, and this is our steering level for weather systems. So it kind of controls what's happening down here at the ground with cold fronts and warm fronts and highs and lows. So this was a favorable environment for flash flooding and severe weather. If you've been with us on some of our event reviews, you'll see the old closed low in the summertime, and that's from a tornado study we did. That's our type A, which is the most dominant for tornado events here in the Northeast. But the other thing to point out is you've got a lot of southerly flow up the East Coast. See, these barbs are pointed from the bottom of the screen to the top. So it's out of the south. So we're bringing up moisture all the way from the southeastern states right up the East Coast into our area. So we've got some tropical moisture coming into play as well. So these are really the ingredients for both flash flooding and for severe weather. A couple of things we can look at here, precipitable water, and what is that? That's just the amount of moisture that's in essentially the column of air that's above you. So if you were to wring it all out, kind of like a sponge, this would be the amount of rain that you would get. So when we start getting values over 2 inches, that's just downright tropical. So you can see here we've got a nice plume of moisture off the East Coast. These darker green values are upwards of 2.5 inches, and a lot of it's focused just offshore. And typically, we see the heaviest rainfalls along and just west of this moisture axis. So southern New England was right under the gun for some heavier rain as well. And we also have the mean wind in there. This is in the layer from about the ground level up to about 30,000 feet. So again, a pretty deep southerly flow running up the East Coast that Sunday morning. Okay, let's take a look at a couple of soundings. This was the Upton, New York sounding in the morning of July 16th. And it showed, first of all, everything, it's a summertime. So our freezing line is this blue line right here. So notice how much of the sounding, the lower half of the sounding is below that. So we have an above freezing layer. The temperature line is in red. The dew point is in blue. So where they're close together, you have really high moisture. Think about almost 100% humidity. So notice the lines are very, very close to each other all the way up. So we're saturated and we're above freezing. And what that does, it's very efficient for rainfall production. We tend to get these smaller drops that really can wring out the moisture. So the other thing to point out, I talk about CAPE, that's known as instability. So the area in the curve between this red line, the temperature, and this dotted line, this shows us the instability. So notice it goes all the way from the ground all the way up to 30, 40,000 feet in the atmosphere. But we call this tall and skinny. It's very obviously tall, and it's also very thin. It doesn't extend very far out. So this tends to be more favorable for kind of marginally severe weather, certainly heavy rain, and even perhaps a tornado. And you can see down at the bottom of the screen, we have our climatology of this sounding. Has it produced tornadoes in the past? And yeah, that line right there, the light brown line, is kind of showing EF0, maybe even borderline EF1 tornado potential. So we certainly have a lot of what's called directional shear, change of direction and speed with height. We have plenty of moisture available, and we have some instability. So all the ingredients there for some severe thunderstorms. Now, our friends up at Gray, Maine to our north did an extra sounding at 2 p.m. on that Sunday. We typically will do extra soundings during severe weather. And this one showed a similar profile to the one we saw from Upton. However, notice the CAPE here, this dotted line, it's a little bit less. And this was because there were already storms or convection moving through the region. But at this point, this was in the afternoon as we were transitioning more to that flash flood threat. So notice instability is much less. But we still have a lot of moisture, and a lot of it's above freezing. Here's our freezing level up here. So you're over 10,000 feet. It's at about 14,000 feet. So again, very favorable for heavy rain as opposed to severe weather by that point. So we'll take a look at some of the SPC mesoanalysis maps, which are always good to look at. This is first the CAPE, the instability. This is at 11 in the morning. And notice it shows some instability maximized over the region, primarily eastern Massachusetts, parts of Rhode Island, upwards of about 1,000 joules per kilogram, even 1,500, that's pretty good. Not too bad. For this area of the country. It's on the really hot, humid days, we can be upwards of 2,000 or even 3,000. But for the most part, most of our severe events are kind of in that range. If we look at lapse rates at both the lower levels and the mid levels, and these are, again, lapse rate is change of temperature with height. So the quicker the temperature changes or more of a temperature drop, that's more favorable to help those updrafts really grow. And typically in New England, it's rare for us to see very strong lapse rates at either the low or the mid levels, and this was no exception. These were pretty poor, so it's really tough unless you have a lot of instability, which again we really didn't have. It's hard for those updrafts to really shoot up high in the atmosphere and form severe storms. So one nice field we like to look at is something called differential divergence. You're saying, what is that? Well, it's taking almost the venting from the jet stream. So as the air rises, it eventually has to be almost like exhaust. So that exhaust is called divergence, and it comes as a result of both jet streams at the lower level, maybe around 3,000 to 4,000 feet, and also at the upper level, so more like 30,000 feet. So what this shows here is where that's located. So where you have the red and the blue and the purple, kind of together, that's where you're really kind of maximized. So see, earlier in the day, we had some lift from the upper jet here where it's in purple, some in the red as lower levels, but mostly in our area out of the upper jet, similar by early afternoon. And then later in the day, you can see we've got both the low-level jet coming up the East Coast as well as the upper-level jet as well. So a little more organized activity could be expected later in the afternoon, Sometimes it usually forms on the nose of this as well, not so much within the jet itself. So by 2 to 5 p.m., we were certainly getting under more favorable conditions on a larger scale to really get that lift going and help the thunderstorms develop. Other things we like to look at for the severe potential are called shear and helicity. So what is that? Well, shear is just, again, it's a change of wind direction or wind speed with height. So the stronger the shear, the more, rotation you can get. And helicity is just something, a nice term for spin. So we look in the lowest layers, so up to about 1 kilometer, think that's roughly about 3,000 feet or so. And then we can even look down to 500 meters, so maybe down to about 1,500 feet, really in that lowest levels. And a lot of the research that we've shown indicates that from 0 to 1 kilometers, you want to have helicity over 100, which you can see we kind of have here. And it doesn't have to be right over the area, but in this case, it kind of is for West Brookfield. And then at the 0 to 500 meter level, we're looking for values over about 95. So we certainly have that as well on a larger scale. So keep in mind, these SPC maps are kind of on a larger scale. So things going on at storm scale, like neighborhood scale, can even be higher than that. But this really gives us a good picture of kind of the near storm environment, as we like to call it. What's your potential for severe weather? So another thing, looking down again, we're looking in these lowest layers for these types of tornadoes, and we're 0 to 3 kilometers, so the lowest 6,000 feet. And we're looking at the instability or the CAPE, which is in red, and also something called surface vorticity. Again, that's just like spin. So where we have the red and the blue kind of together, those are favorable areas. And note, at 11 a.m. on that Sunday, we've got a favorable area over kind of eastern Massachusetts. You can see both are kind of located over each other, even to a lesser degree here in central Massachusetts. And by 5 p.m., where does it go? Well, it kind of is moving off the coast. You can see the blue contours have moved off Cape Ann and are moving up into Maine. So we're kind of lost it here, and we're more involved with just more of the instability. So at that point, we definitely knew that the severe threat was kind of early in the game, and then we'd be kind of losing that a little bit later as the best activity shifted into Maine. So one thing we can look at too are kind of these combination products, and these are also useful just for a quick look. One is called tornadic tilting and stretching, and this really just talks about low-level tilt and the stretching of that horizontal spin. So think about it, if you're spinning like a pencil horizontally near the ground, that's obviously not a tornado. You want to get it into the vertical. So it's that tilting, the updraft, that can kind of take that horizontal spin and move it up into the storm and make it vertical. And that's where we get our mesocyclones and our tornadoes. So the higher the number, the greater the chance. And SPC notes that in some of their testing, when you have values of 2 or higher, that should suggest a really greater potential for these tornadic supercells. And we certainly had that day. Another thing to look at is, can we get these low clouds? Can we get the funnel down to the ground? So we looked at something called the lifting condensation level, and that's simply the height where the air has become saturated. So think about it as like your cloud base. So in New England, we look for these heights under 1,000 meters, and especially under 800 meters that really have shown to be our discriminator. In this case, we're around 500 or between 500 and 750. So we're definitely favorable in there. We can put another check mark there for tornadoes. So the North Brookfield tornado was an EF0, and early that morning, the Storm Prediction Center, we were chatting with them, and they put out this mesoscale discussion talking about scattered thunderstorms, which had developed in eastern New York and were forming in western Massachusetts, with the increasing, a risk for some brief tornadoes, and they were monitoring for the possibility of a tornado watch. And lo and behold, a little bit later, it is at 8:20, which is kind of early, right? We had a tornado watch come out for much of New England from Long Island up in through Connecticut, Massachusetts, New Hampshire, and Maine. Again, talking about a moist environment, strong low and mid-level winds, adding to that shear. So there were, the capability of tornadoes and localized wind damage. So at 10:31 a.m., here's a look at kind of what happened. And showers and storms are moving through central Mass, and you can see one storm here in Connecticut caught the attention of our radar operators. There was a tornado warning there up near Nashua at the same time, but this was the storm. And typically what we do is when we don't see, very tight circulation, but know the environment's favorable, we'll put out the severe thunderstorm warning and issue a tag saying a tornado is possible. And you'll see that down at the bottom of the warning. So this was issued at 10:16 in the morning and included, North Brookfield, not West Brookfield in that case. And we did include information that, we had a tornado watch was in effect until 3 p.m. You can see the storm is kind of over Stafford Springs, and there was some velocity signature with it, which we'll take a look at in a minute, but also mention a tornado can develop rather quickly in this kind of environment. So there was an EF0 tornado, and these are a couple of pictures, really just some tree damage. The storm survey that was conducted estimated the peak winds at 80 miles per hour. The path length was about 2 miles, and the path width about 250 yards at its maximum. Fortunately, no fatalities or injuries, and very short-lived, only about 3 minutes, which is very typical of these types of tornadoes, but did affect and cause some damage in North Brookfield. So we'll take a little bit closer look at it. And here's the loop, first of all. I hope this loop's well enough. The red square is kind of where the tornado occurred. And you can see really, not too much is apparent there as it loops through. You can see a little bit of what we call a pendant in our reflectivity. And there is a bit of a couplet too, and I'll point that out again as it loops again. Here comes the couplet. You can see right there. It's kind of broad, but it does tighten up very briefly right about there, and then, broadens up again. So it's very, very short-lived. This is our correlation coefficient, where we normally will see a drop if we see any debris, but note there was nothing there. Again, we're looking up pretty high in this place too. It's about 7,000 feet or so. And in this called ZDR, which is differential reflectivity, we look for values near 0, which will be gray on this color scale. And we really don't see very much there. This is indicative of updrafts, but also drop size and shape. So we didn't really see much of a signature here. Not surprising for an 80 mile per hour EF0 tornado, but we did have the couplet there, which certainly was indicative that, something was going on. So if I stop the radar here 1 minute before, this is 10:55. Notice, and actually it's a little bit north of where the square is, but notice we've got a little bit of an appendage here, which, we would expect to see. We've got a weak circulation. You've got inbound here, outbound here. So you've got this counterclockwise circulation, but it's not right against one another, known as gate to gate. There is a little bit of what we call a ZDR arc. See how these higher values north of North Brookfield are kind of all aligned, and that's indicative of strengthening updrafts and almost size sorting. So in the storm, the larger drops are being shifted to that size of the storm, and that can be a precursor of a tornado. But again, no lowering here of the correlation coefficient. So not much of a signal. If I were to warn on this, I definitely would have done the severe thunderstorm warning with the tornado possible. I certainly think that was most appropriate for these types of short-lived tornadoes. Okay, so on to the second event. We're moving on now to July 21st. And this was another round of thunderstorms with torrential rainfall, and was primarily flash flooding was the big thing. These are photos from the Deerfield Police Department. And you can see some really, significant damage. Water across roadways undermined and eroded. This was especially hit Conway and Deerfield. So no surprise, Conway hit 21 inches of rain in the month. They were really hit hard during this event. And you can see the observed rainfall in western Massachusetts on the left of the CoCoRaHS reports. We had a report of 7 inches there in Conway, a little over 6 as well, in your Conway and Deerfield. Much of this fell in a 3 to 6 hour period. So that's pretty impressive. And on the right is our radar estimated rainfall. You can see over 6 inches in this lighter pink shading over Conway and Deerfield, and coinciding with a lot of terrain as well. So whenever you add heavy rain in some of the hillier terrain, that's usually a recipe for some pretty significant flash flooding. So these totals actually had a recurrence or return period of about once in 75 to 100 years. So certainly a rare event. This is something we kind of puts the event in the context. Every year you kind of have a chance, but on average you'd see this about once every 75 to 100 years. So one of the tools that we use is called MRMS, Multi-Radar Multi-Sensor. And you can Google this online and actually find it from the National Severe Storms Lab and use it at home. This gives us estimations of stream flow, and there's a couple of ones that we look at. First is this hydrophobic, which really is intended for urban areas or impervious, areas where you have pavement. So think the bigger cities, Worcester, Boston, Hartford, Providence. The more urbanized locations works very well. When we get out into these more rural areas, we use something called unit stream flow, crest unit stream flow, and that's a little more conservative. You can see it doesn't light up as much as the hydrophobic does, but it really helps us with predicting the flooding on these smaller rivers and streams. So as you can see with the terrain, the greatest impact certainly occurred in that hilly terrain around Conway and in through Greenfield. So in eastern Massachusetts, there were also some pretty good rains as well. You may have remembered rainfalls of 2 to 3 inches fell within 1 hour, and these are the Kokoros totals that were observed the next morning. Again, most of this fell in just a few hours' time. You can see a pretty good corridor of 2+ inches right along kind of the Route 9 corridor from Framingham and Metro West into Boston. And this was also the event where at Fenway Park the Red Sox were playing the Mets on a Saturday, and the game was postponed, and the rain was just kind of flooding right into Fenway Park. So that was no fun having to be there. The game was made up the next day. So looking at the hydrophobic unit stream flow, again, this is for the urban areas, and this certainly applies for this part of the state. You can see really where the greatest impacts were, right along that Route 9 corridor, Framingham over to Wellesley, Newton, Brookline in Boston, and even areas of Revere and even down into Quincy as well. So kind of the Route 9 Mass Pike corridor really felt the greatest effects, really, again, just in a few hours as these storms moved across. Okay, so on to the third event. We're getting there. This was an active, again, continuation of the active pattern. You may remember the most significant event from this was a tornado in Keene, New Hampshire, just over the border, and many reports of wind damage across southern New England as well, mainly right along and just south of the Mass Pike. And we also had some strong rip currents. If you remember, there were pretty strong south-southwest winds, helped build up the seas and the surf, and unfortunately, there was one fatality on one of the south coastal beaches. So let's go back upstairs. We'll look at the 500 millibar level, again, about 18,000 feet. This was the evening before, and you can see, again, we've got that ridge dominating in the southwest. That's the heat. But notice we've got this big band of what we call the westerlies going across the northern tier of states, and a little bit of a dip. Here's our trough across the Great Lakes, which would eventually help produce the severe weather. And from our tornado study, this was a type B. So this is a less common tornado producer than our type A's, but it is one of the dominant patterns here in the Northeast. And typically we have, strong southwest flow aloft, which we certainly have here. You can see the wind barbs are pointed southwest to northeast, and usually some upper jet, what we call dynamics or lift, which we certainly, when we see strong winds like this, we know those are kind of in play as well. So our radar loop, let's go through the whole event. This is about a 6-hour period from 2 to 8 p.m. You can see the storms initially, were kind of on their own. We call those discrete storms or isolated storms. And they eventually organized into small lines as they moved through southern New England. And it's those small lines that really produce our damaging straight line winds. The one storm on its own moved through Keene, and that's the one that produced the tornado. So let that go through again. You can see, again, as the line moved toward this Mass Pike corridor, that's when it really organized into lines. Here's your tornado up in Keene from that storm on its own. Then these kind of fill in as they move across Connecticut, Massachusetts, and even Rhode Island. And those are called our bow echoes, where we get our wind damage from. And we'll take a look at all that in a little more detail here. So some of the storm damage we had some pretty impressive wind gusts. Actually, the airport, Barnes Airport in Westfield, the weather station reported a gust of 66 miles per hour. And even up in Blue Hill in Milton, a gust of 61 miles per hour. And here are some damage photos, from Westfield and then Columbia, Connecticut, and even Attleboro here in eastern Massachusetts. A lot of down trees, down power lines, typical of straight line wind damage. So we also had a question during this, was there a tornado near the Mass-Rhode Island border just over from Woonsocket? And we had this on social media on the left from Route 146. Someone had sent this to us and said, boy, that really looks like, a funnel cloud, or was it a tornado? So we went back and looked at the radar here, and you can see those two images here in the middle and center. Definitely what we call a bookend vortex. So what does that mean? When you have a little line of storms like this, the northern end, you can sometimes get a circulation on it counterclockwise that can form a tornado. And it certainly looks like a hook is definitely trying to form there. You don't really need to use too much of your imagination. And if we look at the velocity data, remember the radar is off to our right. So we've got some inbound greens and some outbound reds. But notice they're not right against each other. There's a little bit of spacing. But it's right along the Mass-Rhode Island border there. This is looking at about 5,000 to 6,000 feet up. There was really nothing right at the lower level. So I'm looking at a scan that's a little bit higher up in the atmosphere. But there really was no sign at the low level. So certainly reasonable that a funnel cloud could have formed, but just never made it to the ground. And, we scoured the area for reports, and there simply were no damage reports as well. So I don't think that's one of our, scary looking clouds, as we like to call them, or our low hanging clouds. This probably was a legitimate funnel cloud. It just didn't have enough to quite get down to the ground, which I'm thankful that wasn't the case, didn't cause any damage, but certainly interesting. So leading up to this event, our forecasting, the expectations were for a pretty big severe weather day, if you remember this. Our early morning forecast discussion really highlighted the potential. It looked like we were going to have a pretty big day. Our forecaster even wrote, without hyperbole and while there are uncertainties, the type of environment in place is uncommonly, if rarely seen in southern New England. We had a lot, very high instability, a lot of low-level wind shear, as we talked about. Not a June 1st, 2011 day, but certainly, one of the better days we've seen in some time. So we figured, we really need to amp up the messaging a little bit, and we certainly did that in both the forecast discussions and with our emergency managers. You can see we had a message here to our TV meteorologists, and we talked about this rare combination in place, and we could have multiple instances of thunderstorms with initial cells, which really that's kind of what happened in New Hampshire, and then that second round of those line segments producing wind damage. And with such strong winds in the lower levels of the atmosphere, we have potential both straight line winds and tornadoes. And talked about that tornado risk. It was a little bit farther south than where it ended up, but just as the last sentence says, an uncommon, kind of blend of ingredients for southern New England. So we wanted to make sure this just wasn't going to be, potentially our typical severe weather day. And ended up, there were a large number of events. It wasn't quite as big as we thought. We were saved a little bit by the instability being a little bit less, but certainly the potential was there. And we kind of wanted to, kind of ramp up our messaging a little more than we typically would do for severe weather here. So in forecasting the event, we can look at the short range ensembles, the SHREF from the SPC. And again, all of these are available online. And this is just a combination product that shows us where we have instability and strong, essentially, wind shear. And you can see pretty much targeting over eastern New York and western New England. Usually a pretty good predictor of where, our severe potential is greatest. And something that we're starting to incorporate as well is machine learning guidance. This is kind of the new frontier in meteorology and with our weather models. You'll be seeing a lot more of this in the next 5 to 10 years. So we're kind of in the early stages, but our friends at Colorado State are producing this guidance as well. It's something you find online, and you can see on these probabilities, pretty high for both tornadoes, even wind damage, and here and wind damage there, and even hail. So what these do is they use machine learning. So think artificial intelligence goes back over past events. That's how the machine learns from these things and can really enhance our probabilities, especially these longer time ranges. This is day 2, but we have guidance now out to day 8, which is fantastic. It's not subjective like we would be as humans, where we can't. The chance is too low at day 7 or day 8. Well, the machine learning certainly has really good skills. So I encourage you, take a look at this, some of this machine learning guidance that's out there and available, especially from Colorado State. Another one is also from being worked on with SPC is called NATOcast, and that's also available. It's in experimental mode right now. You can do a quick online search or use the link you see there. This really applies extensive feature engineering on mean and probability fields of the HREF, which we show quite a bit, and also the SHREF. To predict the storm report within about 25 miles. So again, this is machine learning guidance on top of high resolution models. So we're kind of getting the best of both worlds. And boy, look where it nailed, right around Keene, New Hampshire, for the highest probability. And keep in mind, 5% doesn't sound like a lot, but it's actually pretty significant to have that within, for a report within 25 miles. And the wind damage too, maybe aligned a little bit, more to the northwest, southwest, northeast, but highlighting that potential across Connecticut and Rhode Island and Eastern Mass. So pretty good, I would say, overall. From the Storm Prediction Center, we had, similar guidance, slight risk with kind of rather high probabilities of tornadoes, 5%, and even for wind damage up at 15%. So an event that was really well forecast. And again, while the risk of 5% may seem low, it's actually about 25 times greater than what you would see on a typical July day. So, definitely a significant kind of number. So let's go through and forecasting the event. We'll talk about the mesoanalysis a little bit here. And that morning, we had our mesoscale discussion come out from the Storm Prediction Center, talking about the threat for damaging winds and a tornado would increase, and that the watch issuance was likely. So once this goes out, then we normally get on the phone with the Storm Prediction Center and our neighboring offices to kind of talk about it a little bit. And Later, we had a severe thunderstorm watch come out, and the question we kept getting on that was, well, why wasn't it a tornado watch? And so in our pre-watch call with SPC, they were really discussing that the expectation was that wind damage would be more prevalent, which actually it was. Although certainly there was a possibility of one or two tornadoes in the watch area, and there was the one up in Keene. So in talking the event over a little bit, initially, some of the initial storms could pose a tornado risk, but overall, we were expecting a transition to those lines and segments capable of producing wind damage. So that's why it was really a severe thunderstorm watch and not a tornado watch in that case. And it turns out, SPC had the right call on that, and that's why, they are really good at predicting these large-scale severe weather events. So we did see thunderstorms develop early in the afternoon as in eastern New York. This was ahead of that shortwave. Remember I showed you across the Great Lakes. We had a combination of pretty high instability and strong low-level shear. So this is our GOES satellite loop. You could see the tops blowing up in eastern New York, and eventually this activity would work its way into southern New England and even central New England. So at 2 p.m., here's the environment, plenty of instability. And again, look at these numbers. I mean, we showed 1,000 to 1,500 earlier. We've got 3,500. So again, pretty rare, levels of instability here in southern New England, and very strong what's called effective shear. And effective shear just takes into account the amount of shear through the depth of the storm. So it's kind of more storm specific. We know here in New England, our storms are lower top than they are in the Midwest. So this takes that into account. So notice, but the strongest effective shear is kind of anchored right across New Hampshire, Vermont, and Maine, a little bit to our north. So this is kind of the greatest area of concern for tornadoes at that time. And in the lowest levels, remember, we like to look at those. So our 0 to 1 kilometer values were certainly more than adequate. We're, upwards of 150 at that point. Excuse me, again, favorable values are greater than 100. And at that 0 to 500 meter level, we're in excess of 100, whereas we look for values of about 95 or greater. So kind of pointing things really, widespread severe weather threat, but really putting that tornado threat more to our north in Vermont, New Hampshire, and Maine. And lo and behold, there was an EF1 tornado in Dublin, New Hampshire. This is about a 10-minute radar loop from our radar in Norton. So this is out, at about 7,100 feet. There's really our radar, or the radar in gray, doesn't have a great look at it, but you can kind of see, it's kind of smoothed out a bit because it's so high up, but there is a circulation there, and we'll take a look at that more closely in a minute. And there was a funnel cloud reported in Swansea, New Hampshire, to the southwest earlier as the storm was getting its act together. So here's a still of about the time of the max rotational couplet and the tornado. Again, the features are kind of broad because we're looking up rather high and we're far from the radar, but you can see definitely kind of a pendant kind of signature. You've got the couplet. Again, you've got strong inbounds here near Marlborough and some outbounds there. But again, we're looking up. There is a little bit of what we call gate-to-gate, reds right against greens. This gave us a rotational velocity of almost 37 knots. So that's where we take the maximum inbound, the maximum outbound value, and divide it by 2. So typically we look for values of 25 to 30 knots to be favorable, and this was well above that. The normalized rotation, which again takes into account storm depth, was at 0.89, and typically we look for values of 0.8 or higher. So this certainly met the criteria for a tornado warning. And we don't have any really signature of the tornado debris, which is not surprising. We're up so high at this point. But you can also see that a bit of a ZDR. Remember I mentioned the ZDR arc, which is your size sorting. So the bigger drops, the bigger hailstones are being shifted to this part of the storm, which is a favorable thing for tornadoes to form. So we look for that arc present. So by 4 p.m., we'll get a little bit later in the event now. Notice the storms in Worcester County, they're starting to fragment. We have all this instability, but kind of what's going on? Look, still 2,500 in central and eastern Mass, but the storms are kind of falling apart. It looks like the activity in northwest Connecticut's doing a little bit better. But there's a pretty good wind signature here. In the reds, you're upwards of 35 to 40 knots. So that's over 40 miles per hour. Our anticipation was these storms were going to start to strengthen and probably pick up, and this would start to fill in and could pose a threat to Boston and even Providence, as they move eastward. Well, that kind of didn't happen, but the storms in Connecticut, as I mentioned, were coming better organized. You can see a little bit of a more organized line there, and these would eventually brush northern Rhode Island in a couple of hours. So wind damage was the main threat at this point, but also monitoring for flash flooding where urban areas, especially Hartford, where the storms have been training a bit. So overall, at 2 p.m., our tornado potential, and these were what we looked at a little bit before. Here's our low-level cape, and remember that surface spin, showing, pretty favorable across New Hampshire, even a little bit across Connecticut. Not much in the way of these mid-level lapse rates, not surprising, but our LCL, our lifting condensation levels, were too high down in our neck of the woods. A little bit better, though, in New Hampshire. Notice they're lower than 750, but above 1,000 meters across much of southern New England. So again, these are on a larger scale, but really showed us that the tornadic potential was to the north. By 4 p.m., the Cape and Shear stayed kind of favorable for tornadoes, believe it or not. Notice we've got a good collocation here of the instability in that spin. Lapse rate's not too great, but again, the LCL heights are above 1,000 meters in eastern Mass, much of Connecticut. So really not as favorable for tornadoes as it is up in this area, especially moving into northern New Hampshire and into Maine. So it definitely was trending, less toward the tornadic threat here. It was still present, but definitely more favorable to our north. So let's take a look. The Westfield, I mentioned they had a 66 mile per hour gust. Well, we actually got a pretty good view from the UMass Amherst CASA radar, which is a 5 centimeter X-band radar, it's called. So the WSR 88Ds are 10 centimeter wavelength radars. These are a little higher than that. But the problem is when you have rain near the radar site, which is up near the top, the beam signal kind of gets lost. It's called attenuation. So we, unfortunately, because of all these showers and thunderstorms near Amherst, we didn't get too good of a look at the activity approaching Westover, but you can still see a fairly decent line was approaching at that point. So we know, definitely was straight line wind. And if we look at the velocity data as well, again, it's degraded a little bit because of attenuation, but you can see more or less, and there is some straight line wind in this area, not a circulation at all. It's kind of going outbound. So it's kind of divergent. Notice as it goes through again, the greens are toward the radar, which is toward the top of the screen. Reds are away. So you've got the divergence going on. You can kind of see it right about here, greens and reds. So the air is moving away from the storm. That's an indication of straight line wind damage. So by 5:34, we're starting to see now a classic high wind signature. Remember, we were looking at that line of storms coming out of Connecticut, and they're certainly holding their own. What's called a tight reflectivity gradient. You go from nothing to very high reflectivity in a short distance. We've got a bit of a bow in that. And in the wind velocity here, again, the radar's to the east. You can see we've got some blues in there, which is indicative of winds of 40 knots or greater. So this is a pretty good wind signature. And remember, we're sampling pretty well because these storms are moving right toward Providence and Taunton. So coming right down the radar, we're getting really, really good sampling. So we should have a pretty good measurement of these winds, even though we're looking up just a little bit in the atmosphere. Okay, so now on to the fourth event. And this was the one that produced a tornado, EF1 tornado in Foxborough. This was on July 29th. And the final event occurred just a couple of days later. Again, another instance of wind damage. Certainly more reports down across the mid-Atlantic, but still a number of reports here in southern New England. We even had an early morning storm on Block Island that produced a gust of 62 miles per hour and also had significant urban flash flooding in the Boston area. So it was tough to keep all these events apart from one another. But early morning on Block Island, there was a 62 mile per hour gust from a weather flow station you can see here. And yeah, it was legit. Again, you got this line of storms approaching the island. And notice here on the right, we've got some pretty high velocity. Again, we're looking up at about 4,000 feet. But you can see values, over 30, 40 knots. This is about 49 miles per hour, and it's a little stronger closer to the ground, but still indicative of strong winds. There was a special marine warning out, which is for winds of about 40 miles per hour or greater. And there was damage to a boat that was moored, courtesy of our friend E-Weather, that we found out about down on Block Island as well. That was the only damage report received, but kind of flared up pretty quickly early in the morning. So the old rule of thumb is when you have storms early in the morning that are severe, you tend to have another round in the afternoon, and this was certainly no exception in this case. So the severe storms actually struggled a little bit early in the day. We're looking here, this is early afternoon, kind of a lack, there was some, mid-level, mixed cape or another cape that we look at instability. This is surface, I'm sorry. We had some instability here across Connecticut and into eastern Mass. But, later in the day, I'm sorry, a little aloft. There wasn't much cape aloft. It was kind of focused at the low level. So again, I'll just reiterate, the instability was really down low. It didn't really extend very high up into the atmosphere. So this really limited the severity of the storms and resulted in more of a flash flood threat. And the expectation was we'd see more of this deeper instability after about 4 or 5 p.m. So we'll kind of see how that worked out. But earlier in the day, we did have some flash flooding in Boston. This was early in the afternoon. You can see our hydrophobic stream flow again on the left going through about Newton and Brookline at that point. And rainfall rates of over 1 inch per hour closing in on the city. So another round of flash flooding. Lawrence and Lowell were hit in some spots as well. You can see we had rainfall on the order of about 2 to 3 inches per hour. And again, this is our unit stream for looking at streams, but still lighting up North Andover, even parts of Lawrence and Lowell, some of the urbanized areas. So there was some flash flooding there. So here's a look at the storm evolution a little bit later. You can see from 5 to 10 p.m., you've got the storms organizing into a pretty good squall line, producing wind damage. And along that line, we had a little spin up in Foxborough, producing that one EF1 tornado, which we'll look at in a minute. And you had an isolated storm ahead of the line in north central and northeast Connecticut, which you can see. I'll point that out in a second here, right here. And that one actually formed a funnel cloud right here into Connecticut, which nearly touched down, but actually did not. And we'll talk about that as well. So first, let's talk about the funnel cloud. We had tons of reports on social media of these, pictures like this getting very, very, very close to the ground. And we did have on the radar, we're looking at about 4,000 feet here over Mansfield and Storrs, Connecticut. You've got a bit of a hook, which you can see near the yellow circle. You definitely have what we call gate to gate. You've got blue, which is indicative of 40 knots inbound against some reds of about 25 knots. You've got 30 knots of rotational velocity. So that meets our criteria. No apparent debris signature, which is not totally surprising. But again, we have that arc of high ZDR. Remember, we talked about that. So your higher, most of your bigger drops are being shifted to the western part of the storm, which is indicative of tornadoes developing. So, on radar, I would say, yeah, we probably had a tornado and we had some pictures. So, we were looking to see if we had any damage reports. And even if you look at the rotation tracks, again, you can look on the MRMS website that I mentioned from National Severe Storms Lab and find this as well. This is very helpful for us actually when we do tornado surveys because we can find out where the strongest rotation was. We did have some initial damage reports, but we actually sent one of our meteorologists out there and he didn't find any damage consistent with the tornado along the entire path. We were actually kind of surprised. And, he traveled on this path several times. We also were able to get the Civil Air Patrol to do some flights above this, and they weren't able to find any damage as well. So it was kind of a shock, that we really thought this thing touched down and produced damage, but we really couldn't find anything at all. So again, it was a bit of a surprise. But there was an EF1 tornado in Foxborough, again, over a short distance around the Windsor Drive area off of East Street, near the Mansfield line and Easton line. It was an EF1 with maximum wind speeds of 105 miles per hour. The path length was short, just about 300 yards, and a width of just 25 yards. But you can see here on the inset, we've got the rotation tracks here, and you can certainly see in the same area we had at least some decent rotation. There was also, in addition to that, a microburst or wind damage in Easton and Brockton, a little bit farther to the east, as the storm kind of blew itself out, and I'll show that on radar as well. So here's a loop. This is 8 to 8:39 p.m. This is when it occurred in the evening. And you'll see a brief spin up near Foxborough. We'll talk about that in a minute. So you're looking at, the reflect. Here comes the line here. You'll see a little bit of a nub on the front right there. And that's actually the tornado as it moves here right here through Foxborough. And we'll go through on the next loop and we'll take a look at the circulation. But you can certainly see the line. It's coming right toward the radar. So we're sampling well. You've got these strong inbound winds coming through Walpole, Franklin. When it reaches Foxborough, you'll see a quick spin up right about there, a little bit of a curl, and there it is, and there it goes, and it's gone. And then from that, it becomes more what we call outflow dominated, which is indicative of wind damage. I don't believe there was a debris signature just because there's so much noise that close to the radar. There was some little indications of something going on, but it really was tough to actually declare it. And a normalized rotation showed values of about 0.89, which is, again, is kind of favorable. So just a very brief spin up on the line at that point, but impressive. Another radar we have is in South Weymouth. This is an FAA radar. It's called the Terminal Doppler Weather Radar, and it's designed actually to detect wind shear close to the airport. But it also gives us a really good view of weather. And you can see on these 1-minute images, you've got the line coming down through Foxborough and Mansfield there. Let it go through again. You can see again a little bit of a hook signature shows up. You can see a little bit of a couplet right there, and then it kind of moves on out. Actually, it's down here, Foxborough. There was a little bit of a spin, but again, right about there, and then it kind of wind blows itself out. You got a lot more of these reds, so then straight line wind. So again, it was just a very brief spin up right over Foxborough. So in summary, for all the events, that was quite a bit to cover. This was some of the recommendations from our staff. Always stay on top of the mesoscale environment. So that SPC mesoanalysis page is really, really helpful for diagnosing that. You can really follow the evolution of events and dig into those ingredients. For you, those of you who are maybe do forecasting as a hobby, or if you're a student looking to get into college or you're in college, don't rely on these post-processed composites that we show. Those are good just to give you a quick glance, but really dig into the instability. Look at things like CAPE. Look at the effective shear. For tornadoes, look at that 0 to 3 kilometer layer. Look at the 0 to 1 kilometer layer and really focus on that. And just remember, as a reminder, the SPC maps are kind of based on the RAP model guidance, which is at 12 kilometers. So the parameters can be much different on a storm scale. Think about a neighborhood scale. Those values can be much, much different, but they really help put us in the ballpark. High-res guidance during the event is very useful. The HER model, which is run hourly, uses radar as one of its inputs. So it can really help verify your expectations on the evolution, especially when we transition from severe weather to flash flooding. And as I mentioned, that MRMS flash is really best to use for anticipating flash flooding, especially in the urban areas. We at the office and other offices really rely on it very heavily. It's very useful, really gives us a lot of good lead time on our flash flood warning. So now we can provide much more lead time than we could before. So those are some really good best practices. And with that, we will pause here. And I'm sure we have a whole bunch of questions and comments. So let's go through those, and then we'll get to our weather briefing. So from Karen, I know we usually get these small tornadoes in our area. Why don't we not get the big ones like in the Midwest? We do get those every so often. So remember, June 1st, 2011 was a great example of that. The Worcester tornado in 1953 was a good example, but those are rare. Think 50 to 60 year event kind of things. Most of ours, we're just in a different environment. We don't have, first of all, the miles and miles of flat ground to really help these thunderstorms organize. We don't have the instability, most of the time that's present in the Midwest. We don't have the strong, wind shear that's present there. They have our ingredients, but on a much, much larger scale. So, we do get tornadoes. They tend to be very short-lived, but they can be damaging. It's just a different environment here in the Northeast and actually much of the Eastern U.S. So that's kind of why we have the difference there. Jonathan wants to know about the first inch of snow yet. Well, you got to wait, man. We'll get to that. We'll get to that with our winter outlook in the fall. So stay tuned for that. I'm not even there yet. I'm trying to get through this severe weather. Ronald wants to know, was the parent storm that dropped the tornadoes on the 18th a supercell? Yeah, it actually was. So a lot of these are supercells. They're what we call mini supercells because they don't extend quite as high as the ones in the Midwest do. But they are considered what they're called high precipitation supercells. So there's storms, where our tornadoes occur a lot of times with flash flooding and heavy rain. So these are called heavy precipitation, or think about heavy rain supercells. So let's see, from John, a post-webinar question. Friday rainfall will be from the remnants of Hillary. Okay, remind me, John, we'll get to that in the briefing. Not a problem. From Jerry, the radar signals seem pretty subtle. How much experience do you have to see these with confidence? So actually, we've had a lot more confidence over about the past 5 to 10 years. We took, and you can check on YouTube, we actually have a webinar that we did on Southern New England tornadoes. We did a lot of research on them because it was so problematic trying to issue tornado warnings with any lead time at all. So we studied the environments like I showed you today. We studied the radar signatures, and we kind of got our own guidelines for issuing tornado warnings, and we go through all of that on the webinar. So if you check our YouTube channel, Jerry, you can find all that. And we've gotten really better in about the past 5 years, getting our staff trained on these thresholds, what to look for, and really how to be proactive in issuing warnings. So we've seen a lot of improvement. A lot of the credit also goes to the advances in radar technology, modeling technology, and just all the reports we get from everybody, on social media or other means reporting it to us, so we know that these are occurring. So they are subtle, but now if we know the environment, we know we're kind of on a day favorable for tornadoes. We can get some lead time on them. Let's see. Excuse me. From Carlo, can we use Twitter to send you guys reports of wind damage? And if so, how? Excuse me. Yes. We take them all the time. Just tag us at NWS Boston. And we get a lot of reports actually that way. So we certainly would appreciate, photos or reports of wind damage. It really is very, very helpful during a severe weather event. So just tag us. It's at NWS Boston. Let's see, from Caitlin. Can't remember of this event, but multiple apps on my phone wake me up sometime in the morning with a tornado warning in Newburyport. There was a tornado watch for a while. No, I believe there might have been a tornado warning just to your north. And I don't remember what day it was, but you are correct. So if you're in that warning polygon, your phone obviously has geolocation on it. It knows that you're in that polygon. It will alert you on your cell phone. And that's actually one of the best ways to receive warnings. And in fact, the August 18th event, we know one gentleman who lived in Situate, Rhode Island, who was at ground zero for this. He received the alert. He got downstairs to the basement, and it saved his life. He had glass blown in all over his house. We talked to him. So really, you will automatically get those if you're located there. It's one of the greatest advances in technology, I think, that we have for messaging. From Sebastian, do we know where the summer falls in respect to history in terms of total rainfall for our area? We have to be approaching all-time records in some locations, or in the top 10. Yeah, I believe we're in the top 10. We'll have to go through and run the numbers on that. But certainly areas in western Massachusetts are. I believe much of the area, we are in top 10 wettest summer. But we'll have to take a check of that for our summer review. I know 2021 was also a wet summer, believe it or not, and even though we had the drought last year in 2022, but this is certainly up there as far as wettest summers on record. So we'll look at that for the summer review. From Kevin, how do we educate the public better about a tornado warning and what to do? I spoke with a good amount of people Friday afternoon. They had no idea where to go. It's just, spread the word. We work with our TV meteorologist partners. We put things out constantly on social media. They're in the warnings themselves. But yeah, it's hard. Tornado warnings are more frequent than they used to be because we have better, detection of them now. It's just helping spread the word. And certainly all of you can do that too. You tell your friends, your relatives, your family, your neighbors, this is what you need to do. But we frequently post all that information. We have Severe Weather Awareness Week earlier in the summer. But we continue just to stress, we work again with most people when they see a tornado warning, they put on the television, which is great. So we do work with our TV partners to help have them relay the safety tips as well. But it's hard, we really need to work on educating people more. So the more help we can have, the better. Good question from Brian. Is it me, or are we seeing more tornadoes than usual? I don't remember so many tornadoes in New England. So yeah, in a way we are, and there's a couple of reasons for that. One, again, is the advances in technology. So on our Doppler radar, we see that debris signature. We know there's a tornado on the ground. Also, we have more reports from people these days. So, cell phones, social media, we know about tornadoes when they happen. Whereas, 10, 15, 20 years ago, we may have heard about one, but it probably was more often we heard about wind damage that, probably was a tornado and we just didn't know it was. We just heard about wind damage and that was that. We didn't have the radar data to support it, things like that. So I think it's really just the advances in technology that are helping. Is there a trend in more tornadoes? I would say maybe. The jury is out on that. That's work that I have to leave to the climatologists to really study, and that would take really looking over decades. So it's not something we can have just an instant answer on. But overall, we have been seeing more. Whether that's a realistic trend or not, we just don't know yet. So, and Sheldon, same thing. Is this a record for tornadoes this season? Actually, no. We're up to 8, and it's not unusual. There have been some more active years. The problem is these have all occurred in about 1 month's time. So it's been squished in about a 4 to 6 week period or so, maybe 4 to 5 weeks. So you're seeing a lot more of these more frequently, and it's just a result of this active weather pattern that we've been in. So we'll have to see if that kind of continues. From my friend Nick, age 14. Welcome, Nick. How would the Foxborough tornado formed in a straight line wind squall? Well, sometimes on these lines, you can have little spin ups that occur on the leading edge of the line. It happens when you have very strong wind shear. So again, change of that wind direction or wind speed with height can kind of work against that line and kind of work up a little bit of a circulation right on the leading edge. So that's exactly how that one's formed. If you want to search online, look up QLCS tornado. So that's called, in technical terms, that's a quasi-linear convective system. But just do QLCS tornado. There's a lot of research being done on that and a lot of good material out there from the Weather Service and other places that show how they form, and a lot of good examples. So, Nick, that's your homework. Check out QLCS tornado. And if you want to email me for more information or tell me what you found, that'd be great. We'd love to help you out. All right. Fred, what do we got? Let's see. Friday night, July 22nd storm lasted 2 hours, 45 minutes and dropped 2.83 inches in Natick. Yeah, nonstop thunderstorms, never saw so much lightning. Yeah, those were just aligned right along that Route 9 corridor. So it was just constant thunder, as you said, for almost 3 hours. Pretty impressive, and pretty good light show too. That was pretty cool. From Jeff. Hey, Jeff, our co-op man in Staffordville. Would you say this overall pattern this summer was more of a winter pattern, maybe negative NAO? Yeah, actually it is. Jonathan, where was this in January, right? If you look at, we are in a negative NAO. You've got a big, trough here over the east. You've got a cutoff low near the Great Lakes. This would be a pretty good storm producer, a cold pattern too. So, we'll see what happens as we go into winter. It's been so wet. People are fearing that we're going to turn dry for the winter, but, we'll just have to kind of wait and see. But yeah, this certainly, Jeff, would be a little bit better for some snow if we saw this, a few months from now. From Brian, he's heard that Tornado Alley is shifting eastward. Could we potentially see more and more tornadic storms more often? Potentially, yes. And again, a lot of that goes to just better detection, better reporting these days. But yeah, there has been some research showing things are shifting a little bit eastward now. Even into the Carolinas and the Tennessee Valley, whereas traditionally we talked more about like Texas up through Missouri and up into Iowa. So, certainly we can be more active. Remember, the climate is warming, and we're not going to get into arguments about why, but it is warming. It is getting wetter. So, we should see more thunderstorms overall, and just by that very nature, we have potential for more tornadoes, right? So it just depends on how all the ingredients come together. But yeah, I've seen research on that as well, Brian, that the severe weather pattern is shifting a little bit more to the east than traditionally it has been. Let's see, from Brian. Hey, Brian. His weather station Hatfield had 4.24 inches on the 16th. Oof. And hurt the farmers here in Hatfield. Yeah, actually, the heavy rain, it's been good for gardens, but I know the farmers are really hurting. A lot of the crops aren't happening. They've been damaged by so much wetness, and so that's been certainly one concern. It's a shame because last year it was the drought with not enough rain, and this year there's too much rain, and it's hurting the farmers too. So, hopefully we can get some better conditions here as we get into September. And speaking of September, Matthew's asking, will September be wet or dry? We'll show the long-range outlook. Right now, there's really no signal either way, Matthew. It's kind of the odds are showing equal chances of wet or kind of drier than average. So we'll have to kind of wait and see a couple of weeks as we get into September how the pattern's unfolding. But for now, it's just kind of a toss-up. Let's see. Fred wants to know about the Thursday night forecast for Foxborough. Yeah, I heard there was a concert there, Fred. We'll take a look at that for you. No problem. But it's looking a little bit wet at this point. Not a lot of thunder, but it's looking wet. Brian wants to know how many tornadoes have touched down across all the New England states. I know here in southern New England, so Connecticut, Mass, Rhode Island, we're up to 8. I know there's the one in New Hampshire, 9. There's been a few more, so I think we're over a dozen total. I'm not sure the exact number, but yeah, it's certainly been a pretty active summer here for severe weather in New England. From Bob, any scheduled Norton office tours? Oh yeah, we always get that question. So yeah, for everybody out there, tours are back on, so the pandemic is over. We are allowed to conduct tours again. So, if you'd like to schedule a tour for you or your family or even a small community, we can take up to 20 people at once for community groups. Simply, the best thing to do is you can email me or email our webmaster. The link is on the webpage. I believe it's box.webmaster@noaa.gov. And we can get you to the right person to schedule some office tours. We're more than happy to do that. We're funded by the public, so you're always welcome to come to the office. From Carlo, how do we get information about weather radio sent to the public to keep others safe? Yeah, actually, weather radio is a good first line of defense, a good backup. Say cell communications go down. The Weather Service and NOAA do advertise that. But again, it's by, word of mouth is probably the best advertising. Tell people, have a weather radio in your house. I actually have one, and I keep it on at night just in case there's a severe weather warning, in case the phone doesn't work for some reason. That severe weather is coming. So again, it's just all of you can help us with that word of mouth. Spread the word and let people know. Let's see, from JP, and we'll get to our briefing here in a couple of minutes. I just want to get through some of these questions. Do you expect more wet weather patterns with El Nino in effect for the next couple of years, or was this more of a transitional year? Good question. So we are transitioning into El Nino, so we're not into the full-blown El Nino yet, but we're getting there. From what I've seen, it's going to be probably in the moderate or greater stage, so probably a strong El Nino. And typically we do see, wetter than average weather over the long haul here in the east, and especially along the Gulf Coast. So, whether this is directly related, I'm not sure. It could just be kind of a blip in the weather pattern where we're just getting this activity, or it could somewhat be related too. We're just not totally sure. But overall, when we're in El Nino patterns, we do tend to have wetter than average weather. So odds would say overall would favor that for the next year or two. Let's see. From John, could warming offshore water factor in increasing the low Cape High shear events? Absolutely. So, John and everyone, if you remember back in November 2021, we had the tornadoes in Connecticut, Rhode Island, right along the shoreline, and even down on Long Island. It was a pretty good late season outbreak. And a lot of that instability was generated by the warm ocean waters. So, go back to YouTube, check that one out, the November 2021 tornadoes. That goes through it very well. But absolutely, John, that probably was a big factor, and could be a factor as we head into the fall here as well. Once again, we're looking at above average sea surface temperatures. So that does create a source of instability the later we get into the season. Let's see. I'm just going to try and get through a few of these here. Another one from Caitlin. Let's see. The center of the country is going to be under a large heat dome for a while with storms riding around the ridge. Yep, some over New England. And because of the temperature contrast, do you think this will cause more favorable environments for severe weather at times? It could. A lot of times when we get that northwest flow out of the Great Lakes in Canada, that's a good setup for severe weather, believe it or not. We tend to have a strong jet stream present like we've seen the past few weeks. So, yeah, we could be seeing more favorable severe weather here. Over the next few weeks. We'll just have to kind of see how things play out, but certainly the pattern is there to help. And let's see, from Carlos, 7.7 inches of rain so far in August in South Hamilton. Yeah, many places upwards 7-8 inches already. So absolutely. And Ronald, great point about the weather radios. It is like a smoke alarm, could save your life. That's what we try and tell everybody. Change your smoke detector batteries, get a weather radio, and make sure the batteries go there. And Brian just wants to know about the tour for how to schedule a tour again. What I'll do is I'll dump the email address in the chat. Let me just do that. It's Box Webmaster is probably the best place to go. There we go. Just send an email to that email address. You can, send one to me as well, but it's probably easier to get through to the webmaster. We have a bunch of people checking that. If I'm out of the office, I may not see your message right away. And then what we do is we have an outreach team, and they actually go ahead and schedule the tours. So again, if you want to schedule a tour, email our webmaster, and then we can pass it on to the right person and get you a tour scheduled. So everyone, again, more than welcome to come visit our office down in Norton. And from Brian, let's see. The warming waters off the coast also favorable for a hurricane or tropical storm. Absolutely. And that's something we're concerned about and we'll get to here in a few weeks. Brian in North Andover, 14.5 inches so far. Pretty good. And our friend Jeff over in Staffordville is 25.29 for the summer. So, yeah, I think in parts of Western Mass, they're over 30, but I'll have to double check that. But, yeah, certainly been a wet summer, and we're definitely, I believe, in the top 10. So, all right. At this point, I'm going to go ahead and we will end the recording here.